Make sure all that got in there. Okay. And like I said, all of this is on the solution key. Now, if you plug all that into your calculator and hit enter, that should lead to (0.0102). 0.0102. So that's the standard deviation for this problem. Now, moving on to step 3, we're going to actually calculate the margin of error for this inferential study. Since we only surveyed a sample of voters from the entire population of voters, our sample proportion is only an estimate for the actual percentage of all voters. So there's going to be error involved since we only did a survey based on a sample taken from a population, an inferential study. And the error in step 3 for this inferential study, the formula in step 3 is E is equal to the critical value Z alpha over 2 times the standard deviation you got from step 2. Make sure that all got in there. Now, we found that the critical value for 99.7% confidence from the table at the beginning of the second section turned out to be 3.0. So this is 3 for the critical value times the standard deviation we just computed in step 2, which was 0.0102. Make sure that all got in there. It did. And if you plug that into your calculator, 3 times 0.0102, it comes out to be the error for this confidence interval estimate is 0.0306. So that's the error. And if you think about it, you can write the error this is the error given as a proportion. And if you wrote the error in terms of percentages, you could say the error is, move the decimal place 2 places to the right. It's saying that in percentage points, the error is 3.06 percentage points at a confidence level of 99.7. All right, so now we move on to the step 4, which is to actually make our confidence interval now using the sample proportion and the error. So we're going to subtract the error from the sample proportion and then add the error to the sample proportion, and then that will give a range or an interval estimate for where the population proportion should lie, at least with this confidence level. And so moving to that last step, step 4, before the interpretation, step 4 says the confidence interval estimate for P is given as P hat minus E to P hat plus E. Sample proportion minus error, sample proportion plus error as an interval, and that's equal to, the sample proportion was 0.536. So it's 0.536 minus the error, which we just computed to be 0.0306, to 0.536 plus the error, which is 0.0306. So we go from 0.536 minus 0.0306 to 0.536 plus 0.0306. And I'm going to have to erase because I'm at the bottom here. And if you do that, that then comes out to be the interval from 0.505 to 0.567. So that's the confidence interval estimate for the population percentage of all voters in the population that voted for Bill. The only thing left now is to put the interpretation. Now, if we wrote this as percentages, this is based on proportion, population proportion. If we based it on percentages, it's the same thing as saying the interval from 50.5% to 56.7%. You just move the decimal place 2 places to the right, here and here, and that gives you a confidence interval based on percentage, population percentage, and this is the confidence interval based on population proportion. See if I can get that in there. Okay. Now, what's the interpretation? Well, I'm just going to read the interpretation here, which is printed there. And what you'll say is for the interpretation, this is step 5, it's equivalent to saying there's a 99.7% likelihood that the actual population percentage of voters that voted for Bill should lie somewhere between 50.5% of the population and 56.7% of the population. So with 99.7% likelihood, the percentage of voters that voted for Bill should be between 50.5% and 56.7%. So that should be good news for Bill. Now, because it's an inferential study, no confidence level is based on 100% confidence. So that means there's still a 0.03% chance, or probability of 0.0003, that the actual population percentage of voters voting for Bill is not between these two numbers. So this only says with 99.7% likelihood, or with a probability of 0.997, the actual percentage of voters voting for Bill should lie between 50.5% and 56.7%. There's still a small chance, a 0.03% chance, or a probability of 0.0003, that the percentage of voters voting for Bill is not between these two numbers. But there's a high likelihood that the population percentage voters that voted for Bill is between 50.5% and 56.7%, which means there's at least a 99.7% chance that Bill's going to win the election. If there's only two candidates in the election, and Bill is, with at least this probability, is going to get at least 50.5% of the vote. So that's one way that you can use confidence interval estimates to be able to draw conclusions. Just like whenever they're calling states in a real national election, and as you may remember back in 2000 when they called the state of Florida for Al Gore and then had to recall it for Bush, using their exit poll numbers, they came up with a confidence interval estimate that seemed to suggest that Al Gore had won Florida. But because there was always a small percent chance the interval estimate could be wrong, there's always going to be in a confidence interval a small chance, 100 minus the confidence level, that the actual population percentage is not in the confidence interval. So there's never 100% certainty associated with a confidence interval estimate. It's only based on the given confidence level. So that's problem 6. Now we're going to do a problem 7, which is similar, but it's going to be a confidence interval estimate for an unknown population mean. So now we're going to have measurement level data, not categorical data, and we're going to estimate a population mean using sample statistics from an inferential study. So we'll have the sample mean, the sample size, the sample standard deviation, and the confidence level. So for these problems, and this comes out of chapter 21, confidence interval estimates using measurement level data, where you're estimating population means from sample means or sample statistics, you have to get 4 pieces of information from the problem before you can plug into all the formulas you need. So what I need in problem 7 is to read it and extract the sample size, the sample mean, the sample standard deviation, and the given confidence level. Then I could use those values in the next 3 steps to get the margin of error and the confidence interval estimate for the unknown population mean. So let's read problem 7. In problem 7, it says, suppose that a random sample of 325 American households were selected, and a representative from each household in the sample filled out a survey where they provided their gross annual income for their household from the previous year. So that means that they randomly selected 325 households, and each household provided their gross annual income for their household from that previous year. So what we're trying to estimate here is the mean annual income of all American households. And we're estimating that by only sampling 325 American households at random. So from that random sample, where we get 325 annual incomes for 325 randomly selected households, it's determined, because you could plug those data values into Excel and calculate your sample statistics. So it was determined that the mean of the sample, which we use as X bar, was $34,620.43. So that's the mean annual income of the 325 randomly selected households in this survey. We're also given the standard deviation for the sample, which is little s, to be $8,314.28. That's a measure of how spread out the data is, or how far the annual incomes deviated from the mean income on average in that sample. We're also given that the sample size was 325, as I mentioned, so that's N. N is the sample size. So sample mean, sample standard deviation, sample size, and the only other thing that's given that I need to track is the confidence level. It says here we're estimating the unknown mean annual income of all American households at a confidence level of 95%. So the confidence level for this problem is 95%. Now, if you want to go ahead and get the critical value for the confidence level now, because you know we're going to need it for the margin of error, you can go back to the cheat sheet at the top where it says Section 2, Chapters 20 and 21, and on the cheat sheet there in that little table, it says that when you're at a confidence level of 95%, the critical value for the confidence interval is 2.0. So that's the critical value we're going to use in our margin of error formula here. That's the critical value for a confidence level of 95%. All right, now, let's go ahead. I'm going to sort of move this over a little bit, like here, so I have a little more space. And let's go through the steps. Step 1. We're going to calculate the error. And if you look at the formula in the cheat sheet, for this confidence interval estimates of unknown population means, the margin of error formula given in step 1 is the error E is equal to the critical value Z alpha over 2 times the sample standard deviation S, all divided by the square root of the sample size. So that's how to compute the margin of error for an inferential study where you're estimating an unknown population mean. And if you plug the numbers in now, we know that the critical value here is 2, so we plug in 2. The given standard deviation was given to be 8,314.28. And then we divide that all by the square root of the sample size, which is the square root of 325. So we take these numbers. Notice we're not using the sample mean to compute the error. We're only using the critical value, the sample size, and the sample standard deviation in this formula to get the error for this inferential study. And if you plug all that into your calculator, you get that the error comes out to be $922.39. So that's the error, $922.39.